Wow. This is how it's going to be.
Yes, sorry.
Hello?
All right, hello everyone. We're going to get started in a few seconds from now. So, well, welcome to the last session here at Hadoop Summit. We are here to talk about what PayPal actually is doing in terms of Hadoop and big data, and how actually we are trying to accelerate behavioral analytics at PayPal, and what does it really involve. With that, we will start with a very quick introduction. We are a part of data platform team at PayPal. The way our agenda of the team is to help analysts about the community at PayPal get access to the data in the way they will like it, anytime, anywhere, or any place as they describe it. As with any other company, our platform is divided into multiple components. Some of the few components are the part of the workspaces, modules, and the engine, which actually is missing in the slide. I'm not sure why. And these are the distributed components of our platform that we are building. My name is Rahul, and I'm the PO for the platform team. And here with me is Alexei, who's the technical lead for the platform. Yeah. So with that, let's go on to say that what exactly PayPal is trying to do with data, or what are the use cases of data today prevalent at PayPal. So let's look at some few of the business use cases we have, like how actually PayPal is trying to use the data. The first one, as you know, PayPal is a major payment company today. So one of the biggest benefactors of the data today at PayPal is risk. Like when a customer comes actually to make a payment at PayPal, we want to make sure that we limit the fraud before it happens, we detect it, and we don't allow it through our systems. And that's one of the major use cases of data we have today at PayPal. The second one, demand gen. Like how do we reach out to our customers? How do we give them a better offers? Or how do we make them more engaged with our products? The third one, the product. From an interaction on a site or on a website all the way to transaction, what is the experience a customer goes through, and how we really can improve it so we lead to better conversion in terms of our products, in terms of our payments. And the last one, how do we really get more feedback back to the merchant, or telling them what they're doing with the data, or how we are enabling the merchants to grow in their businesses. With that, let's take a look at one of a very simple flow of what really happens when you try to make a transaction at PayPal. You go to merchant website, you say that pay with PayPal, it calls API, then you go through the different phases, you log in, we check the fraud, we lead to authentication, and after you confirm, once you get the shipment done, and which leads to actually the money being deducted from your PayPal account. Now, in this entire flow, which seems very simple in the diagram here, let's look at what really happens in terms of data, in terms of the needs. Well, what really happens is that this entire simple flow at PayPal generates around terabytes of raw data. But for our analysts, directly dealing with the raw data is really not what we need. What we need is for them to describe a business view of that data, saying that, well, this is what customer did. This is what the customer was seeing, not a log, not a record in a table. And that's what we need to get from terabytes of raw data all the way to a metadata-defined managed data sets. Second point, now, if you look at our systems, these are many different systems working together to make this flow happen. And in that flow, we get data from click streams, we get data from server logs, we get data from transactions. But what our systems need is a single unified access to find a behavior across these channels, across these data streams. They are interested in knowing what a customer did all the way from start to end, not what happened in an isolated system like, let's say, a transaction, or in a system like clickstream, but what really happened in a customer experience all the way from end to end. And the last, each of these leads to around millions of transactions a day, billions of server events a day. And how do we really make processors or modules which allows users or analysts in our community to find really meaningful data from there, meaningful insights from there? What is a pattern? What is a flow? What are flow of things which happen in there? How I can easily get access to that? And these are some of the use cases we actually are typically looking at. So with that, describe what are the uses of the things and what are the data we have in the system today. Let's look at how we try to get to how we can enable analysts in our community, in our PayPal, to better get access to the data, faster access to this data. So with that, we started saying that, let's start building a data platform. And we said, what are the design principles we need to have to build such a platform which enable analysts to quickly get to the data, yet not be bogged down about the complexities of Hadoop or big data, which brings to analysts who have been using SQL for so many years. So let's look at that. We said that why not first give them one common framework in which they can actually describe what they need. So it's very simple. If you look at it, we say that, OK, how about what we have is there's a source of data, a user can describe the data, or analysts can describe the data, and developers can provide different plugin parsers which can actually help you read different formats of data, be it delimited, be it sequence file, JSON, any other format in that sense. We said, OK, fine. But the people who are describing the data are our analysts. And for that, we say that how about we give them an interface? So the analyst who actually knows the data can easily describe the data back to the users. They say that, well, my data which is coming in, without writing a piece of code, they can say that my data which is coming in is a collection of a name-value pairs, is a query string format, is a delimited format, and this is how I describe the data. And once they do that, what our system actually can take is take that input from the analyst on the data and actually translate the data to a common format or common representation, which anybody in the company actually can get access to. Think of it something like a metadata, crowdsourcing metadata in the company. Like once a user comes and describes something, the data is self described, and user actually use those attributes. You can use the definition actually to use the data more. So with that done, we said, OK, what is the next step? So we have a first framework to actually take the raw data and make it something more meaningful. But we didn't stop there. We said, OK, what is the next step from there? We said, OK, how about we allow business users to describe the metadata, saying that what does it really mean? Well, a click is interesting, but it's very mildly interesting. If you look at analysts, what they really need is saying that this was a page for my business, which meant that a user started a flow in PayPal, and which is the flow means. We said, OK, how about we give them a system in which they can actually describe what those events are? So we said that we build a library for tags and relations, and what that really means is a user has described a click, and now you as end user or analyst can go and say that this is a click which is meaningful to my business, and they can actually, our system will start building the collection of clicks. Not only that, some of the clicks can be certified, which means anybody in the system knows that they are using it and they are meaningful, they are actually true. Or you can start prototyping with it by saying that these are only my collection of clicks. That's it and done. So we built first. We said that, OK, we have a framework to translate data. We have a framework to define or tag data. How about we build an analytical framework in which user can describe common uses of patterns of data, which is taking this data, translating it from, let's say, translating the data from events all the way after metadata, and then figuring out a flow of events, saying that what really happened in a transaction flow or in a payment flow. Or I want to know patterns of events which happen somewhere. So we say that, OK, the next one, we build a module and a job system on top of that on that platform in which user can go describe some modules, and he can go and run those as jobs. The output of the jobs can be directly connected to our enterprise warehouse, and the enterprise warehouse, which leads to a user can actually query the data from using SQL, which is actually most of our analysts use today at PayPal. Or they can connect it to Tableau for visualization. Not even that, we actually have a very cool pathways also built tagged to D3, in which they can actually start looking or exploring data, and we'll talk about that as we go along. Yet, what we say that the same developer who wrote a parser, who actually gave you the ability access to that data, the same developer can now also actually write processors, which become plugin modules for you to build your workflow upon. So you can say that now I want to build a path module, I want to build a pattern module, I want to build a state machine module. And these modules actually become connected to the data they have because all of data is tagged, is cleansed, is represented in the same common unified format. So all of that done, we say that, okay, how about let's say that you have tagged your data, you represent your data. Let's look at the next step, what they can do. Imagine that you as analysts are looking for clickstream data, and you want to know what really happens in IP address. For a given IP address, how really the stream of events went. So what you really say is that you say that, hey, my key for the analysis is a IP address, which is described here on the left, and these are the sequence of events I'm interested in. And these are all a drag and drop. So you can go and define it, and you can just drag and drop on the UI for the analyst to say. And he can say that, well, I'm interested in these 4 events which happened in this sequence. I know the start point, I know the end point, but I don't know what really happens in between. So he can mark them as optional, saying that, let me know if it happens. If it doesn't happen, well and good. So once an analyst describes his workflow, and he can run this job system, and post that running this job system, what really happens is you can start looking something like this. This is a visualization made using D3. saying that this is what really happened. This is how people found out when they actually came to a website. This is not really complete, but what it says that this is you started, these are pages you started with. From these pages, how you actually go and navigate to our website. The diameter, the bigger the circle, the bigger the content of that page was, the bigger the visit or the number of people to that page was. And actually, all of this, the power that comes here, is all of this what I described or talked about till, the analyst who actually is working with this tool has not written a single line of code yet, be it MapReduce, be it any scripting language. He has been only using the UI or the GUI tool to describe his workflow, to describe what his intents are, and he's really content with doing that. And once he gets access to data, our tool actually allows him to go and use the data to build his workflow, to do whatever he wants to do with that data. So we say that that becomes our blueprint on building a platform. This is what we want to get to from the raw data. This is how really we want to make Hadoop reach to our analysts without actually giving them or without them having to invest in the complexities of Hadoop for the learning curve required. So as you look at what happens, our system actually becomes now two subsystems. One is the first input processing, where a user can actually describe his data, can tag his data, can define his data. In the entire system, we don't lose any data. We still preserve the raw richness of data. We only do is we transform it and store in a format which is more conducible to, let's say, a big data platform like Hadoop. And in the second step, what we do is we build upon top of that by providing simple aggregators logic, by simple logic which users can use to define his workflows and allow him to run and connect it to various enterprise visualizations or EDW tools we have today at PayPal. So with that, describe the system, I will hand over to my partner, Alexei, here to talk about the architecture of the system, what the system is really doing, and how it is being built.
OK, so let's talk about how we really process the data and how we make it available for the data processing. And the first and maybe the most important part is data acquisition. How to bring the data into the system and present it in the way that is suitable for data analysis. At PayPal, we have a lot of different systems, different data sources that generates log files in different formats, like sequence files, delimited files, fixed length formats, and JSON formats. So, and this is why for us it's very important to have a system that can understand all those formats and transform the data to some common data model. And this is why we implemented this flexible, metadata-driven transformation engine that can consume definition which is defined in our configuration tool, and create event objects that can be later easily used for data analysis. So we have that MapReduce job that runs, consumes metadata, and based on that metadata, it knows how to process source files and generate event objects. And as soon as events are generated, we store them in HDFS using in a sequence files. In order to make the new data available, we need to register that data in the system using our data catalog API. At the same time, during the data acquisition, during the data load process, we have an ability to extract some reference data and store it in HBase table and for future data analysis. And I will show you some example in the next slides. So the main objective for the system is to be able to process data from different sources, different formats, bring it to the same common data model of event objects. But it doesn't it's not only about transformation. We have an ability to enrich our data, our events, using that reference data that we extracted on the first step, and then at the same time find and define some relationship between objects. So let's take a look at one example. So let's have a sequence of events, and as you can see, all those events have the same session ID, but only the last one has customer. So based on that data, during the data load process, we can identify that there is a relationship between that session ID and the customer. And we can save this relationship in our reference data in HBase in order to make it available for a next step of processing where we can fill the gaps in the data and resolve those relationships for the missing for other events. This is why we have a multi-step data load process, and one of the steps is entity resolver. This is when we go through all the events and try to fill the gaps in the data by doing lookups to HBase table. So at the end of the data load, we can associate. So at the end of the data load, every event has session and customer ID, and this data can be easily processed later on. Of course, it's not just hard-coded for session and customer. All those entities are defined in our metadata, and we can have an ability to specify different type of entities like session customers, web cookies, and define relationship between them. The next component that we'd like to talk about is our implementation of data catalog. As I mentioned before, we process the source data, we convert it to event objects, and keep them in the sequence files in HDFS. In addition to that, we implemented some additional layer of API that can abstract this file management functionality from our clients. At the same time, it helps us to partition and to index data based on metadata and metrics available in the data. So when we load the data into the system, we call data catalog API in order to register this new data in our EAP system. And at that point, we can collect some information, some metrics from the data, store them into HBase table, and use it to index and partition the data. So currently we have user can query data either with MapReduce or pig. And for example, when we want to extract data using MapReduce, we need to first make a call to data catalog API to request the file locations based on some filter criteria. For example, we can ask about the data for a certain date range and source type, and maybe by event type. And then data catalog API will return set of paths in HDFS, and then MapReduce job can process them directly. So, as mentioned, currently we support support pig or MapReduce job. And in order to use and query the data from EAP using pig, we need to register our jar file and then use event loader, which supports certain filter criteria for the data, like time source, events, attributes, and entities. From the MapReduce job, in your MapReduce driver class, you will need to get to use data catalog API again to query the set of files based on, again, certain filter criteria. And then you will need to define your mapper and use our event class in mapper declaration. So, I talked about the way how we can access the data, but how we can make the data analysis easier for end users. And our approach is to build a library of reusable modules for most common use cases, such as path discovery and pattern matching. So the users can build their jobs based on those modules and apply some additional logic on top of that using MapReduce or pig. So let's take a look at some numbers. In order to process data, we have two environments. One is exploratory cluster, which is kind of R&D environment where users can run ad hoc jobs and analyze the data. So there is no SLA, any SLA provided on that cluster. At the same time, we have another production cluster, only where we run our production jobs and with strict SLA, and no ad hoc jobs are available there. Data streams. At the present time, we have 2 daily feeds, which is about 300 GB a day, and 1 hourly feed, about 50 GB per day. And the amount of data is growing every day, and we are looking to add more and more data sources. For the processing time, it takes about 15 minutes to process 100 million events and to resolve 20 million entities in each base. User jobs, one of the use cases for flow analysis takes about 5 minutes to process 40 million events. And in order to extract about 200 million events, it will take about 10 minutes in our cluster. And every cluster is about 600 nodes.
Well, with that, we come to an end to our presentation. We wanted to keep it really short because we realized it is the last session for the day, and all of us are really looking forward probably to that. In case you guys have any questions, we definitely will take the questions right now.
So how many analysts do you have using the system, and do you put restrictions on the type of jobs that they can run on it?
Not currently. Right now, we don't have any type of restriction on the jobs they can run on. The user community we have around, let's say around 20 or 25 analysts actually trying to use the system today and just get the extraction from the data. And that's what we actually are stands as of today.
Thanks.
As far as the process for enriching the data from the reference database, it looked like you were actually, in the example, you had the session ID in a later record.
Right.
And then you were basically back mapping that to older events.
Yes.
Do you keep like a window of like validity or something, or?
Yes, we have a window in which we resolve and go back in the time to resolve those references. Yes.
And was that in MapReduce?
No, yeah, it's one of the configuration parameters for MapReduce. So our data load is two-step process. So first we convert source data to the events, and the next step is we are trying to resolve entities and enrich the data with missing relationships.
And would you actually have like historical data points, like say like a changing state over time, like say like the balance or something, that you could denormalize to all events if you wanted to?
Currently, what we do is we store, let's say, around 7 days of data for our lookups. And in that lookup, what we allow the users to configure, saying that, for instance, let's say you want to find in a session what was the customer, because customer is not, when your customer comes to a website, you don't know who the customers are till they log in, mostly. So what we say, the analyst, you can define a rule such that you can say that how you want to look, how you want to enrich the data. Do you want to go look back in time? Do you want to go look forward in time? Is it one-to-one relation? But not around changing state of data. We don't do something like that right now.
Thanks.
Yep. All right, thank you for attending. Thank you for attending the Hadoop Summit, everyone.
Thank you.
When the sun goes